It's quite amazing when you see science fiction turning into science fact. I remember with The Incredible Voyage thinking about, could that ever be that we shrink people down and get into our bodies, and now we see it, or being able to actually live up on the planet. We have an amazing panel now set for you. It's a manel, I'm sorry. It's about the future of quantum, and where do these three individuals think it is going to go, and what will that mean for us? So I'd like to welcome our guests. Come on up onto the stage. Let's give them a hand as they come up. Mikko, Ricardo, and Fausto. Welcome to the stage, to the Puzzle X stage. And now we are here. So we're going to, first of all, gentlemen, and again, I apologize for the mantle. So who are you, and why are you here?
Good morning.
Good morning, good morning.
Well, I am Ricardo Enriquez. I am a physicist.
Say it again, because they didn't hear you before.
I am Ricardo Enriquez.
Yep.
My background is on physics. And I'm working at Repsol. And I'm the leader of the quantum group at Repsol.
Okay.
Recently, a couple of years ago, Repsol started the quantum journey. And we made some strategy linked to the energy transition.
Okay.
And the organization asked, Ricardo, why don't you take a train and meet some other nice people and talk about that? And I said, okay.
So that's why you're here.
Okay.
Okay, cool. Okay, Mikko.
Well, thanks for the invitation here. I'm Mikko Möttönen. I'm a quantum physicist by training. Made it up to a professor of quantum technology at Aalto University and VTT in Finland. Well, here I'm representing IQM, which is a quantum computer company. I and three other co-founders, we spun it out about 3.5 years ago from my research group at Aalto. Okay. Now we have more than 200 people on a mission to build world-leading quantum computers for the well-being of humankind.
Great.
And why I'm here
why are you here?
Is that one of our key core values in the company is collaboration. So we want to work with the Spanish, European, global ecosystem to really make those quantum computers useful for the humankind.
Great.
And I'm really looking forward on the networking here after this panel, for example.
Great. Thank you. And last but not least, Fausto.
Yeah, I'm Fausto. I work in Silicon Valley at BMT Watson Research Center, New York. My background with multiple PhDs and masters is really a tech one. But as computer scientist and mathematician, I moved to pharma 5 years ago, and therefore I'm working in London for GlaxoSmithKline as a global R&D tech head of innovation, data science, and emerging technologies. The reason why I'm here is that Zina thought that it was nice to have a guy like me that can bring a perspective from the healthcare point of view, or the biotech point of view, or the biopharma point of view. And I'm honored to be here with all of you and the panelists, so it will be a very interesting discussion.
Wonderful. Wonderful. Well, thank you very much. So, the title of our session is The Future with Quantum. What is your vision for, say, 30 years from now? What's it going to look like for the future of quantum? I'm going to start with you again.
Okay.
No, I'm not going to start with you. I'm going to start with you.
Okay.
You're not going to get the first time each time. Okay.
My turn.
Yeah, your turn.
Yeah, great. Well, my vision for 30 years from now, what I think is that we are going to have a useful general purpose quantum computer that is scalable. So we can scale it up, and we can basically attack all sort of known applications of quantum computers. That seems to me very likely or feasible in 30 years' time. So the world will be very different.
Okay. So I've got a question, though. Fusion has always been about 20 years away. Is quantum going to be the same?
That is a very bad point of comparison, because in fusion, it's the stability of the plasma, how to make it to produce more energy than it's consuming.
Yeah.
In quantum computing, we are taking steps, incremental steps that in the end will lead us to the general purpose quantum computer. We are increasing the qubit count, which is maybe now not the most important, but maybe the most important is to make them higher fidelity. So make the qubit more accurate. And there has been a tremendous progress in the hardware. Every year you see amazing things happen. And also in the software, in the algorithms, they're also developing very quickly. So you can see kind of this hardware-software gap to shrink and shrink.
Okay.
That's something you maybe don't see that much in the fusion.
In the fusion world, okay. Well, maybe if we talk to CERN, they might have a different view, but I'm sure I'll share your view. So, Fausto, what about you? So, where is it going to go? 20, 30 years?
My God, that is a very difficult question. I don't know where it's going to be in 30 years, or if it still will be around. Probably it will be, because considering all the investments that we are doing, and after even assuming that it will be a better technology, the barriers to entry will be too big at that point to modify the whole ecosystem, like it is happening, and it happened for a lot of other things. But I can give you some examples that, from the algorithmic point of view, instead of the hardware point of view, I think will become more a kind of reality 30 years from now, even faster. Everybody's talking about drug discovery. Let's leave out drug discovery at the moment, and we can explain why later it is important to have quantum for drug discovery. You know, quantum, there are too many people that are focusing on trying to solve very difficult problems that require a lot of computational time in quantum, and the error that they are doing is that they are focusing only on the class of problems that is called NP. That means that if you have a problem of this size and it's taking this time, and you try to solve a problem of twice that size, it's not going to take twice the time. It's going to take thousands of years, because essentially the computational power that you need to solve a problem of double size is much greater than twice. It's growing exponentially. But why you do that? I mean, quantum is amazing, in my opinion, to solve things much faster. Doesn't matter how the computational power that you need is growing during time. So, you know, drug discovery is only one case, but think about virtual reality. Today, a lot of things cannot be done, simply because virtual reality would require too much computational power. But 30 years from now, with all those kind of haptic interfaces and sensors and other things, quantum can make it possible, and it is part of the future. Drug discovery, everybody's talking about protein folding. Yes, but protein fold is only one of the things that you can do. Do you have any idea how many materials you need to source from how many countries to create a new drug and assemble it and sell it? There are single products that require a supply chain that is passing through more than 20 countries. It's a big computational problem that maybe linear optimization solvers can today solve, but that today can be done at a completely different level of resilience for much, much even bigger, more complex, personalized medicines, and that quantum can make possible.
Okay, great. Thank you. That's a good pause point right there, because I want to get to Federica. No. I just want to give everyone some equal time. So what about for you? So 30 years, 10 years, 20, you're looking a little bit closer. So what's your vision? Tell us your vision. Tell us your time frame.
Yeah. First, let me say that there's no future without a past.
There's no future without a past.
There's no future. And the
quantum this is an esoteric thing to talk about right now.
Quantum theory already revolutionized Repsol. I mean, quantum phenomena called photovoltaic effect. It was the Nobel Prize for Albert Einstein. Led us to have some PVs and some photovoltaic electricity and distributed energy at the landscape, the energetic landscape of mankind has changed.
Yep.
And we are facing the energy transition. In fact, Repsol was the first company all over the world to announce the net zero emissions commitment by 2050. So we see quantum computing as an enabler, as a key technology related to this energy transition, to this net zero energy. So I cannot guess how the hardware will be. I mean, I don't know if it will be a standalone quantum computer for general purpose problems, or it will be some kind of hybrid solution, or even other paradigms of computing, like one-way quantum computing will appear, and so. But what we are sure is that we will have the capability to make the ab initio calculations. I mean, for materials discovery, for catalyzed design, for a lot of technology related to energy, we need to do a lot of experiments. And we need to do a lot of machine learning, and a lot of people need to be done there. And the theory behind that, even it is not so precise.
Okay.
So we will have the accuracy to do things by computing.
Okay.
If I come back to 10 years, that's probably 30 years. If I come back to 10 years, probably we have some problems where we can do that, but not in all the problems we have. And if we move to 5 years, probably we will have found one single case or two single cases where some quantum advantage is present.
Okay.
And probably that will be the NISC devices where we will find, and that will be the push for the rest of the search.
Okay. So let me. So when I listen to you guys, I think of two things. Two things come to mind. One was, when we went to the moon, we didn't come back with great riches, but the journey was phenomenal, and it changed all of our lives around the world. Everyone's, really. Is quantum sort of like, I don't like to use the word moonshot because that's been taken by certain groups, but is it sort of like this? It doesn't matter if we achieve this, or is it because we're learning so much, or is it really going to happen, and that's the goal? Mirko, what do you think? And then you have an opinion on that too.
Yeah, I think it's in a way both. That in the pursuit of the general purpose quantum computer, we will of course need to develop technologies along the way that can be used outside quantum computers, maybe in sensors, communication, somewhere else. But also there are these sort of milestones, midpoints on the way. So maybe you're not going to the moon, but you're going to Alpha Centauri, and your moon is your first stop.
Right.
This would be for me the first useful quantum advantage. With an ISK machine, and that I think, well, actually for our company, it's the main target now. But of course, it's only a milestone on the way to the full thing. But that is the most important milestone, I think, now for the field.
Okay, so but what about you guys? So you reacted to that very clearly. You don't agree?
Yeah,
you agree?
I don't agree.
Fausto, I want you to.
Because a lot of people say this is like going to the moon. And going to the moon.
Well, let's say Alpha Centauri, okay?
Okay, Alpha Centauri is more or less the same.
Okay.
It's a technical problem.
Okay.
But it does not change our vision or our understanding of reality. And that probably is very important, and it's very, very differential with quantum computing. Quantum computing, we are somehow discovering new ways of representing reality by itself.
Yeah.
So probably, I don't agree because I am in love with the space career, for sure. But I think it's probably more similar to the birth of the internet.
Okay.
Because we know that will be something great, really great. But we cannot imagine all the things that are going to happen.
So I would disagree with you on one thing. I can't remember which of the astronauts said we got to the moon and what we've discovered is Earth, the little blue ball looking back. So there's a perspective change, and so maybe there could be a perspective change because you're discovering all sorts of things with the hardware, with the algorithms, with the challenges which we can be facing.
The brain.
So we're understanding our brain more. So what about you? So what do you think? Is it the goal or the journey when we're looking at the future with quantum?
It's the journey. We will never know what we will find, but it's important that we try to discover it all together, right?
Okay.
It's like classical computing. You go in a direction, but things become clear only as you are doing them. It's impossible to plan ahead all what will happen. So it will be interesting to discover if quantum really the right thing for everything, or if it is right for what. And we already see that kind of fragmentation, I think, even in the algorithmic world, that nothing is so good for everything. And therefore, for me, it's the journey as community in discovering more and learning.
Okay, Mikko,
Yeah. So it's just funny thing that I came to my mind here when you were discussing is that so many people have asked me that when is your quantum computer ready?
Yeah.
My kids ask it, my mother asked it, our investors, they ask, when is it going to be ready?
And what's the answer? What's the answer?
And I always tell them never. Because if it's a journey, it's never going to be ready, right? We're always going to make it better. It's like, are your mobile phones, are they ready? No, you want a better phone next year or maybe 2 years from now.
Yeah, but they work properly.
And you know another problem? Take AI/ML, right? There is so much genetic material that if you can create an AI/ML classifier from the quantum point of view, you can do things much faster. to discover anomalies and assess. But if there is no explanation for causation, and you want to leverage ML and AI just from the correlation and purely statistical point of view, it doesn't matter. Quantum can really become a kind of an atomic bomb. You can really go far away, but not knowing. Like deep thought. Do you remember deep thought? What is the answer of the universe? Works 40 years, 43. So no interpretability.
42. Hey, come on, get it right. Yeah, dude.
No interpretability at all. So we need to be careful. Quantum is a lever, in my opinion, but how we use it will make a big, huge difference, especially if we have a causation kind of interpretability from the algorithmic point of view, and not like today.
Okay.
Where you have
So when we think of a future with quantum, there's some things we were discussing it briefly before, right out front. This issue of the expected and the unexpected, right? And of course, the unexpected you can't really expect. Otherwise, it's not unexpected. But you were sort of intrigued with this, and I was intrigued because quantum is something for me which I still have a hard time getting my head around. As a non-physicist, non-mathematician, you know.
Yeah.
But tell me about what, when we were talking about what was in your mind about expected versus unexpected future with quantum. Federico.
Well,
Ricardo, sorry.
yeah. It's not an easy question. But, okay.
But you like those. Come on, I know that.
Yeah. Probably what we can think about what is expected is the roadmap anyone we have done for our own sectors and the timeline we were discussing previously. Okay, next 5 years I will have this device, I will have this problem, and then I will have this other problem, and then finally I will have. But in the meantime, in the journey, we can find, and we are dealing with a technology that is quantum. I mean, I was probably you can expect to get a better understanding of some phenomena, like, for instance, space-time, quantum gravity. How to use the energy of space-time by itself, start thinking about. We were thinking about nuclear fusion. What can do quantum computing to represent this plasma in a better way, to understand materials and to understand and to reach nuclear fusion and to accelerate nuclear fusion. But probably the more transversal is the really unexpected. It's something like the internet I was mentioned previously.
Yeah. Okay.
It's like the brain, the understanding of consciousness. And probably if consciousness we can understand, can we storage? Can we move consciousness through a network? Can we translate entangled people? Who knows? The unexpected. Yeah.
We'll see what happens with that when it kind of goes with the last little bits of the previous presentation on the psychedelics, perhaps. That was maybe helps it connect. So what is this? What about for you guys? When expected, unexpected?
Yeah, well, I'm expecting the unexpected to happen, and I actually wish
there you
it
go.
will
I
happen.
like that. Yeah.
Because, like many companies that build quantum computers, they say that no, they are going for the general purpose machine where there's error correction, and then you can solve.
Yeah.
You know, there is a path, theoretically known path, only theoretically known, by the way, and that is also not fully known theoretically, to basically solve many problems of interest. But what I really am expecting is an unexpected invention of a new algorithm that we can run in a quantum computer with, let's say, 100 to 300 qubits with reasonable fidelity, even maybe without quantum error correction. That would give some commercial use case. Okay, that would be kind of. I'm expecting that the first quantum advantage, the usual quantum advantage, will come from that kind of an unexpected invention. Well, of course, it's possible that the existing algorithms, they are, like I said, they're being improved and improved. It's possible that those will bring the first one. But I'm expecting something unexpected to happen there.
Okay.
Some probably.
Yeah.
Not unexpected.
Okay, I like that. All right. So, Fausto, do you want to add something, or should I go to another question?
Either way is fine for me.
Go ahead and add something. It's up to you. You get to choose.
Okay. I hope that we will discover new science. So think about automotive, right? At the beginning, there were a lot of cars. After, things became better. At this point, everybody knows how to build a car in a very cheap way. So again, the algorithmic part probably will be a point of differentiation. And I really hope that with that kind of compute power that quantum can provide, we can discover in a good way things that are unexpected, like it's not possible from the biological point of view to simulate a human today, but tomorrow we can. So you can run virtual clinical trials without really using real people. And there are a lot of things that are less related to some of the things that you were discussing for me, Ricardo, but that are important and I can see can be greatly leveraged in science to understand better the world, simply because today we cannot simulate existing systems in a way that is accurate enough from the computational point of view with a lot of details.
Okay.
It's brilliant.
What's
We
that?
can put a name for that, a quantum twin.
Yes, that's right. I think the name is a good fit.
So, okay. thank
Sorry.
you.
Sorry
No,
about
that's okay. That's okay. So, I'm looking around the world at lots of massive changes right now and challenges, from our climate challenges to geopolitical to migration. Lots of folks know water. We heard a bit about food. So, what's the role of quantum when we're looking at these global existential challenges for billions of people?
Yeah, I think like a lot of people think that quantum computers, they consume 1,000th of the power of a supercomputer. That, okay, that's the green deal about quantum computers. Well, that is, of course, can be true, and most likely they will use much, much less power to solve those problems that they will solve in the future more accurately or faster. However, I see quantum computers as a tool. It's a tool to do something useful for the planet.
Okay.
And it's the handprint of quantum computing that will then be the big green deal about it. So, for example, the chemistry calculations.
Yeah.
Like even if we can now find one sort of way, one new molecule, one catalyzer that will make, for example, batteries better, or make some chemical process much more energy efficient, that would be a great start. And there are a lot of people thinking about how to do it, improving these algorithms so that they could be done with hardware that is, they're going to be faster.
Got it.
Yeah, I agree on that.
Yeah.
I agree.
Okay.
Yeah, we are moving from fossil fuels to more renewable and sustainable. And okay, we need to probably have to have a big share of hydrogen in the future. And hydrogen, you do it, the renewable hydrogen, by electrolysis.
Yeah.
That you need water of high purity. And if you can find catalyzers that you can get hydrogen from
Sure.
seawater, that will be just a single problem where quantum computing can do something, will change probably the face of mankind.
Okay, great. Fausto, you want to add something?
I would like to add a different kind of challenge. Let's suppose that everything is going to happen. I see big challenges in privacy and security that today are completely overlooked. So when the technology will be available, effectively, who will have control of that kind of technology? I hope that will be highly democratized as it becomes commoditized, especially with 3D printing and other emerging technologies. There will be issues because effectively you can do things today that are thought impossible. So masking of the data, who owns the data, what you can really know about a person if you create a quantum twin. There are a lot of prediction capabilities that are important and needs to be regulated, and only governments, in my opinion, can do that. So the challenge for me will be how quantum will change our way of living, because finally there is that capability that allows essentially to predict much better trends and behaviors and dynamics in your body and as society.
In both. Well, thank you very much for that. You know, for me, when I'm going to answer my own question to you, it's really quite interesting thinking, what are some of the grand challenges? Because we need to try to find answers to. If we could solve photosynthesis, right, that would change everyone's lives, literally. Understand it finally. And this is where we think about the hardware, and all of you said, well, the hardware, it's going to keep coming and coming and coming. It's the algorithms that we're trying to figure out how to work with this tool, which you described, this tool, will then help change our lives. And I think that's really quite fascinating. And I really appreciate that. I think Wayne Gretzky, the sort of well-known, he's a hockey player, always used to say his secret to success was he would always think where the puck was going to go, and he would skate to where the puck was going to be ready, then to either make the goal or not. And what's interesting for me, hearing from you, is thinking of where will quantum be so we can skate to be there ready when everything is ready together. And those are the algorithms, the hardware, the challenges. We hope to all read at the right time so that our future with quantum becomes something which is really exciting, which is empowering for all of us. And I think
Necessary.
Yeah, pardon?
Necessary.
And necessary, yes. So thank you all very, very much for staying here with us during this past half an hour, and I hope you have a wonderful rest of the day. And thank you, panel. Fantastic.
Thank you.
All right.